Thank you very much, Rob. And hello, everyone. Again, I'm Eugene Morozov, representing a Freeton community here. And I would like to start by extending a word of thanks to the previous speaker, Brian Nielsen, who has set the perfect background for our next presentation. So as before, we're going to start with a short video by the Chief Technology Officer and the co-founder of Ton Labs, Mitja Goroshevsky, to be followed by a questions and answers session. Gentlemen, please, the video. Thank you.
The core developer of the Freeton blockchain.
So first of all, I would like to talk to you about decentralization and what it means for me. And second of all, about some technical aspects of how we and can we really achieve that decentralization on a global scale, technology-wise. Before we go deeper into details, let's just agree on, well, on the fact that the blockchain revolution is here and the blockchain growth is unstoppable. I mean, if you don't agree with that, you may just stop listening to me right now, because all the rest is based on that. And for me, it is crystal clear that the benefits that technology such as blockchain brings to the world, to the human, is just, to the humanity, is just such that we cannot really stop it, because it would be like stopping progress. And we never actually, we tried. Like the human race tried to stop progress many times and always failed, unfortunately. So everything I say from here on will only be about public blockchain. Now, the public blockchain will disrupt every industry that requires trust, banking and finance. That's already happening. The corporate governance will be, will change when it comes to the commerce, law, internet itself. Okay, the internet itself today is centralized. Well, because most of the time when you use internet, you use things like Facebook, and they just use Facebook. And today people go, I don't know, TikTok, and they think that this is the internet or Instagram or whatever. And it's very, like the most of the time you use very limited number of projects, and you think this is the internet. While the internet, in the beginning, that was like decentralized movement of the freedom of information, which was and still is hugely important for the progress of the humanity. When you introduce the blockchain to the core of the internet itself, if you can do that, then you demonopolize the internet itself, and then it becomes again free and decentralized. Well, we don't have a lot of democratic countries, actually. I know that. And even in the United States, we have these problems of the election process we all know about. And I'm not talking about, of course, other countries where you know, there are a lot of parties who would like to grab the power. And for them, it's even harder. For the people in this particular country, it's even harder or just impossible to actually preserve their democratic rights. Well, the question is now, what can we do, and why we couldn't do that up until now? Well, first of all, of course, it takes just time for the good progress. Like even if you have a revolutionary technology, it just takes time. It takes time to adopt. But the problem is also in the technology itself. Like the blockchain technology today is just not efficient enough to be used because, well, it's not expensive for monetary transactions, right? Because when you're wiring the money, and you're paying a fraction of that, really small, tiny fraction, you don't care. But if you want to put other actions on the blockchain which do not require monetary transaction, for example, just a click. Okay, so you need to click on the ballot, or you need to fill a form. In this, if you fill the form, well, today it's free on the internet, right? But it's centralized. And how much would you be willing to pay for filling out the form? I don't think you would be willing to pay even 1 cent for that. Then, surprisingly enough, it's also too centralized today. Well, first of all, because in order to make it fast, you kind of, you need to centralize it like private blockchains, right? So, but even going further than that, if you look at how today's blockchains, public blockchains are managed, for example, even Ethereum, like you could claim that it's not really decentralized. You need the whole, it's not enough that you have like decentralized blockchain running between servers which run by different parties, right? That's not enough. You also need that the software code that runs this blockchain technology will be managed in a decentralized way. And the governance of this blockchain will be managed decentralized way. Like, for example, most of the blockchains today have foundations, and these foundations are managed centrally, right? So, well, you have foundations, so there are several people who manages them. This is not enough. Like, you cannot put a whole internet in the hands of one foundation. It just, you know, it's absurd, right? And the fourth, it's too insecure. Because in order to present, like in order to have security right now in the technology paradigm that we have, you need it to be slow and expensive. So right now, well, until now, I would say, there was no way to have a secure blockchain, secure public blockchain that would be guaranteed by you know, by enough kind of power, or whatever this power is, monetary or hash power, computing resource power, it doesn't matter, and be fast. So, like, can we break out of this paradigm, and is it already available? Well, for that I would like to talk to you a little bit about Freeton and what we're doing. So, well, this is the most complicated slide up until now, and you know, this will be the last one, promise you. That just an overview, and this very fragmented overview, because I couldn't put everything in one slide. It would be just not readable. Well, it's already not readable, I admit, but you know, still, this is how Freeton blockchain looks. So first of all, this is first and only multi-threaded, multi-sharded blockchain. And when we talk about multi-threading and multi-sharding, well, the best analogy to that is a modern processor. Dozens of years ago, we had a processor which had one core, one thread. And that was very easy to program, very like kind of easy to construct. But then we hit the laws of physics of the single crystal, and that was just not possible to increase the speed of this processor anymore. Each program will occupy its thread. Right, the blockchain up until now, if you compare that with the processor, up until today, all the blockchains just were running in one core, one thread. You can only execute one smart contract at a time, basically. And that's how Bitcoin works. Well, Bitcoin doesn't have processing capabilities so much because it only has like very limited scripting capabilities. But the Ethereum, which introduced the smart contracts, these smart contracts are still executing one after another in one thread, like in old computers. What Freeton is introducing is, and by the way, all that I said, now it works already in Freeton currently, right, in production. So it's a multi-threaded, multi-sharded blockchain, means that it actually runs like virtual multi-core processors and execute smart contracts in parallel. And that architecture allowed us to break the world record of transactions per second, which happened a few weeks ago, and we achieved like 52,000 transactions per second. And actually, like this was with 400 validators. If the validators, if we would have more validators, we would, you know, go much further than that, because it's actually like you can scale it almost infinitely. You just add processors, and that scales. Right? So we can go to millions of transactions per second. We just need enough, you know, computing power for that. And so this is very important. That tackles almost all the what I said before, like now it's not slow and now it's not expensive. Now let's talk about security. Now, can we achieve the security while having that amount of transactions and scalability in the multi-threaded environment? The problem with multi-threading and sharding is that when you shard the data and then you shard the execution, which is a threading, you only having subset of validators to validate the block, which means you actually lowering the security guarantees because fewer parties are witnessing your transaction, and when they're putting the bond guaranteeing your transaction, the total amount of money that is guaranteeing a transaction is lower because it's divided between all the parallel executions, right? So how do we achieve the security? And what we claim in this architecture not only is the fastest and the most scalable architecture in the world today, but it's also more secure than a Bitcoin. And we're doing that by this novel consensus protocol that we have developed, which is called soft majority fault tolerant consensus protocol. And I'm not going into details, but basically in this consensus protocol, there is an algorithmic path on how to verify each block in such a way that the security guarantee is unknown. It's basically, when I say unknown, random, it basically means that the malicious party, when they want to introduce the malicious transaction into the block, they never know that they will achieve, they will be able to corrupt the block. And for them, the risk of this, of running this malicious transaction is just such that it's actually more risky in probabilistic way, more risky than trying to corrupt and reverse the 6 blocks of Bitcoin. All right, so they need more money to actually achieve the probability of enough guarantee and probability to corrupt the block, then you need money to revert the transaction in a Bitcoin. And moreover, if you introduce additional steps to that algorithm, you actually can lower this probability to actually 0. So when you have such a security guarantee on top of the most scalable blockchain, then you can do some things that you have never been able to do before. When we talk about decentralization, it is very important for us from the beginning was that this decentralization is also ensured on the user level. So we have this wonderful decentralized computer with wonderful security guarantees. But if between this computer and the user stands some other parties which could be malicious, then we didn't do anything, right? So for that, we developed the concept that was called end-to-end decentralization. And in end-to-end decentralization, we develop our own browser, basically, and we run some programs which we call dbots in this browser. And by running them, we are sure, and the user is sure, that what it executes on a local machine is actually what happens on the blockchain. And it's guaranteed by cryptography. So let's see if we can actually use all that in some ways that I have described before, in some problematic fields that requires decentralization, but up until now could not achieve it. And one of the same things we did is a project for the Guatemala election audit. So, you know, we and the GBA has worked to help this grassroots movement, beautiful grassroots movement in Guatemala, for the which actually received a GBA Courage Award. And actually, we are in the middle of developing such solution right now, based on the specs that the result of the winner of the contest presented, and they will be tested in 2023 national elections in Guatemala. So, and for us, it's a demonstration that this technology, when it's developed to this level, can be used in real fields, in real scenarios and real use cases, and not only in the cases where where transact with the money, right? So thank you very much for your attention.
All right, thank you. Unfortunately, we won't have time for questions on this one. We're going to need to shift over to the next presentation.